Okay, so let's look at this antiderivative. So, keeping in mind the previous example, right? I want to rewrite this integral, or this antiderivative rather, in terms of a new variable u. And what should I choose for my u? And if you're not sure what that means, right, just scroll back up into your notes. So what is my rule of thumb? Okay, so we actually have 3 different answers. So, you know what, stop typing. This is a perfect opportunity to open a poll. Okay, so the question will be, how should I complete the sentence? So u equals what for that problem? I'm going to scroll back down to that problem so you can look at it again. So how should I complete this sentence? And there's your poll. Okay, well, interestingly, no one said not sure, which is actually really nice. 56% of the students in the chat have said x cubed. Okay, so can someone who voted x cubed, or maybe someone who didn't vote x cubed, actually explain why that is the answer? U equals x cubed. Why did you choose u equals x cubed? It's on the inside function. Good. So x cubed is on the inside, and Matan says x cubed is the internal function that is then an outside multiple of the derivative. I think you just got your words a little mixed up there. I think what you mean to say is x cubed, its derivative is on the outside. But yeah, I think we know what you mean. Right, so that's what we said. And then I think Damien actually also said something. Damien said by sine of x cubed, I think it should be written as sine of u. So I guess x cubed would be similar. So that's actually correct. So Damien actually corrected himself. He realized that sine of x cubed is actually going to be sine of u. So u itself was just the x cubed. Right. So these are all good observations. Right. So x cubed, I'm choosing u equals x cubed because the derivative of x cubed is sitting outside as a multiplicative factor. Right, that is the big rule of thumb for a substitution rule. It's backwards chain rule. Just always remember that in your head. It's backwards chain rule. Okay, so now let's make a translation table. Okay, so what do we start with here? We start with the actual function, right? U equals x cubed. What do I write next? I write my derivative, du dx equals 3x squared, and then I algebraically solve for dx. Now we translate the integral. Okay, so as usual, the 3x squared, I'm not really sure what to do with yet. The sine of x cubed is just sine of u, and the dx is du over 3x squared, right? We only use the first and last parts of our translation table. All right, but now the nice thing is if you did your substitution correctly, right, you should have magic cancellation. Right, the 3x squareds cancel out, and I'm left with just the antiderivative of sine of u du. Now, how do we proceed from here? Notice that I'm down to only one variable, right? X's are not in the picture anymore, right? It's okay if X's and U's kind of mix together, kind of in a middle step, but eventually you want to get rid of all the X's. You want to get rid of and just keep just U. Now, what would be my next step here? Now that I have it only in terms of U, what would be my next step here? Find the antiderivative, right? Exactly. So who can actually give us that antiderivative? Or if Bianca just wants to tell us, or it looks like Matana's typing. So negative cosine u. Good. And then if I want remember, the original problem was asking me for an antiderivative in terms of x. So you should go back and put this in terms of x, but only because it's an antiderivative. When we do integrals later, where there's actually numbers here, we won't go back to x. So the antiderivative is negative cosine x cubed plus c.